So we're going to be talking about the rectangular coordinate system, and we'll be plotting some points and just learning about the parts and pieces of the rectangular coordinate system. We also call this the XY plane or the coordinate plane. I typically will call it the coordinate plane more than anything else. This right here, we call this and this, these are axes. This is the y-axis, and this is the x-axis here. We split this when we create the axes. We split this up into quadrants, and this is the first quadrant. We use Roman numerals to label these, and then we're going to go around counterclockwise when we number the rest of these. So 1, 2, 3, and 4, and those are the four quadrants and their numbers. So if I say something about the fourth quadrant or a point that is in the fourth quadrant, I'm talking about a point that's down in this region in here. That point is going to have a positive x value and a negative y value. And speaking of positive x values and and negative y values, or just x and y values, period. The points on this coordinate plane, we label those as an ordered pair, we call it. So an ordered pair. And that ordered pair, when we write it like this: some x value, comma, some y value. And it's always going to be x first, y first. A good way to remember that is if you think about the alphabet, x comes before y, just like x comes before y here in the ordered pair. So how do we work with this? Well, first of all, a really important ordered pair that's on the coordinate plane is this one here, which we refer to as the origin. And that ordered pair is 0, 0. So the x value for that is 0, and the y value is also 0. And that's our starting point. Whenever you're going to plot a point on the coordinate plane, you're always going to start from the origin. Now, let's say we wanted to graph this point, 2, 1. What we would do to graph that is we would go starting at the origin here, and then we would go over we're always going to go in the x direction first, which is, this is the positive x direction, this is the negative x direction. Maybe I'll label that real quick. So this is the x axis, and this is the y axis. This is positive, negative, this is positive, and this is negative. So as we move in this direction, we're getting more and more positive. In this direction, we're getting more and more negative. This direction, we're getting more and more positive. In this direction, we're getting more and more negative in the y direction. All right, so let's get back to graphing 2, 1. So I'm going to start here at the origin. I'm going to move 2 spaces in the positive x direction, and then because this is a 1 here for my y coordinate, I'm going to go from, remember I went 1, 2, and then I'm going to go up 1. So 2 in the x direction, 1 in the y direction, and so my point is going to be right here. And that is the point 2, 1. If we wanted to graph, say, let's do another point, we'll do negative 4, 6. So again, we will restart. We're going to go back to the origin. We're going to go negative 4 units in the x direction, so 1, 2, 3, 4. And then we'll go 6 units in the positive y direction. That's 1, 2, 3, 4, 5, 6. So that's our point right there. And I'm going to have to count this out again after I switch the tool. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So there is negative 4, 6. Excellent. Now, let's just look at kind of the signs for or I guess you call them sign patterns for our quadrants. So the quadrant 1 is always going to have a positive x value and a positive y value. Think about it as you start here at the origin, you're going to go in the positive x direction, then you're going to go in the positive y direction. That's always going to get you up here into quadrant 1. The quadrant 2 is always going to have a negative x value and a positive y value. You're going to start at the origin, you're going to go in the negative x direction, and then you're going to go in the positive y direction, and that'll get you up here into the quadrant 2. Quadrant 3 is always going to be negative x value and a negative y value, and then quadrant 4 will always be a positive x value and a negative y value. So those are kind of our sign patterns for the different quadrants. And then I should mention, if you wanted to graph something that had a 0 in it, like 0, 2, this one is going to be, you're going to start here at the origin as always. You're going to move 0 units in the x direction, so I'm just going to stay right here on the origin, and then I'm going to move 2 units up. So this point right here is 0, 2, and then if I flip that around and we do something like -4, 0, you're going to start at the origin again. You're going to move -4 units in the x direction, so 1, 2, 3, 4, that's right here, and then you're going to move 0 units in the y direction, so boom, there's your -4, 0. So notice when you have a 0 either in the x or the y, you're either going to fall on the y-axis or the x-axis, depending on where this 0 is. If the 0 is your x-coordinate, you're going to fall on the y-axis. If your 0 is in the y-coordinate, you're going to fall on the x-axis. We've talked a lot about equations and solving equations, and we actually, in our class, we've had a few equations when we were working with the word problems that had 2 variables in them. And then we quickly substituted one variable in for the other, and then we had a 1 variable equation we could solve. Now, here is a 2 variable equation, and the solution to a 2 variable equation like this is actually going to be an ordered pair. So if you solved this equation, you'd get something like this, x comma y, and that would be a solution. And in fact, there's with a linear equation like this, or a 2 variable equation, you have an infinite number of solutions. I can find a whole bunch, well, an infinite number of x values, and then the corresponding y value that would solve this equation. And we'll look into this. Remember, a solution to an equation is just something that creates a true statement when you substitute it in for the variable or variables in this case. So we have an equation that looks, something like this. And this is our standard form of the linear equation right here. So the standard form this is the standard form of a linear equation. Ax plus by equals c. So a and b are non-zero. And they don't have to be, but typically they're going to be integers. But once you get out into the workforce and out move up in math, you're going to have variables or coefficients that are decimals and fractions and all that. So what we need to do is we need to start finding some of these solutions here. And a way to do that is just to make an XY table. So let's say we had this equation, y equals 2x plus 3. So this is going to be our equation, and we're going to calculate some solutions to this. And so what we'll do is we will create a little XY table. And the book is going to add one more column here. I usually just have X and Y, but they're going to have what the ordered pair looks like after you calculate your X and Y. And so what you're going to do is you're just going to start selecting X values. 0 is always an easy one. And so what I will do is I'll plug in, or I'll say, and you can do it off to the side somewhere. I'll just do it right here. So when X equals 0, I'll have Y equals 2, and then I'm going to, wherever I have an X in my equation here, like right there, I'm going to plug in a 0 into that equation. So I'll have 2 times 0 plus 3. Notice everything is the same in this equation, except all I've done is I've substituted 0 in for X. When I say the same, I mean the same as this one here. And so I solve for Y. This is 0 plus 3. And then I'll just get Y equals 3. So when X is 0, Y is 3. So my ordered pair that is a solution for this equation is when X is 0, Y is 3. So this is one of the solutions, one of the infinite solutions to this equation. Let's find another one. Let's plug in 1. And so when X is equal to 1, notice I have to do this whole process again. When X is 1, that's going to be Y equals 2 times 1 plus 3. So Y is equal to 2 plus 3, or Y is equal to 5. So when X is 1, Y is 5. My ordered pair is 1, 5. Here's another solution to this equation. So again, remember, we have infinite solutions to these linear equations. So let's plug in -5, and I'm going to move over to this side. So when X is equal to -5, notice how I keep track of that, of what I'm plugging in for X. I have Y is equal to 2 times -5 plus 3, so Y is equal to -10 plus 3, Y is equal to -7. So -7. So my X, or my ordered pair, is -5, -7. Yet another solution. All right, our last little bit here. So here's a new equation. I've got Y equals 4X minus 8. And we want to know, is this ordered pair a solution, and is this ordered pair a solution? So we'll just check them each individually. And the way we do that is, remember, this is my X coordinate, this is my Y coordinate, so 1, -4. I just plug these in for X and Y. So 1 would be X, -4 would be Y, and then we check to see if it makes a true statement. If it does make a true statement, then it is a solution. If it's not a true statement, after plugging it in, then it's not a solution. So -4 is what we plug in for Y, and then 4 times 1 minus 8. And we want to know, does this create a true statement? So we've got 4 minus 8. 4 minus 8 is -4, and that equals -4. So yes, this is a solution. Let's check 5, -12. Y, forgot to plug in. So remember, 5 would be my X value, -12 would be the Y value. So we'll plug in -12 for Y, and then 4 times 5 minus 8. So just evaluate the right-hand side. It's going to be 20 minus 8. This is -12 equals 12. These are opposites. They are not equal to each other, which means that these are not equal. And no, this is not a solution. So that's how you check to see if an ordered pair is a solution to an equation.